Thank you. It's a pleasure to be with you today. So I'm Jeremy Epstein. I've been working in the cybersecurity field for over 30 years now, since long before it was called cybersecurity. My day job is with the National Science Foundation, where I lead the largest cybersecurity research program in the world. We have somewhere between 900 and 1,000 active research projects going on, some of which are voting. And I'm also the chair of the voting committee of the Association for Computing Machinery's U.S. Technology Policy Council, which is the public policy arm of the biggest association of professional computer scientists in the world. So what do the experts say? Well, if you talk to experts about voting, you get the answer that you see on XKCD here. If there's anyone on this webinar this discussion who is not familiar with XKCD, make sure you take a look. Very informative, technically interesting cartoons that address difficult problems in a very succinct way. Basically, the problem is we don't know how to build secure software. You may hear from other folks that, oh, we know how to build this securely, it's perfect, but it's not the case. We have hacks every day. If we knew how to build secure software, we wouldn't all be patching our devices constantly. It just wouldn't be happening. So let's see, why did that stop advancing? There we go. So there are a bunch of policy issues that we need. I'm sorry, I missed that one. Okay, so is blockchain the answer? This is a great slide developed by the Department of Homeland Security to try to help you figure out, is blockchain the solution for the whatever problem you're trying to solve? And this is a great way to figure it out. And it turns out that for many election-related needs, blockchain is a good thing. But for voting, it's not, because if you go through this flowchart, you'll see over and over again, you don't have multiple organizations contributing data. It's not a good thing that you want to share all data with all users for all times. For example, if there's a vulnerability in the encryption method and I can find out who you voted for 10 years from now, that is a significant threat. That's why physical ballots get destroyed after a reasonable period of time after the elections, to prevent these sort of things. That's why we ensure that voters don't write their names on ballots, things like that. Blockchain does away with that potential of long-term voter privacy. So some of the policy issues we should be addressing for internet voting in general and blockchain voting in particular: does it enfranchise or disenfranchise voters? Well, it depends who you're talking about. Many Americans, and this is true in other countries as well, do not have smartphones, do not have access to high-speed internet. So solutions that rely on this increase the bias in our elections today. It's very hard, coercion is very hard to prevent in any remote voting system, whether it's paper or internet. One of the few solutions is Estonia's multi-vote model, where you can vote as often as you want, but only the last one counts. That only works because every voter has a smart card and there's a lot of other technology behind it. It's not a simple thing to do. What are the impacts on election offices of doing, say, blockchain voting? Potentially fewer poll workers. That would generally be a positive thing, but you need a lot more tech support to deal with the complexities. Digital identities are a big challenge if you're doing blockchain and having to issue every voter a digital identity. Is it going to increase or decrease public trust in election results? I know we can say as techno geeks, oh, everybody can see this because the blockchain is public. But it's more observable in some respects, but it's less observable to non-technical experts. They have to trust their friendly neighborhood blockchain expert, and most people are just going to say that's magic. Today, with paper, we can look at it. Yes, there are some problems, as have been identified, but we address some of the problems with paper with appropriate countermeasures of having people from both major parties or in other countries, even many parties, observing. You just can't do that in blockchain. It doesn't work. And what are the long-term risks of blockchain voting? What happens if we discover a vulnerability in the software, or there's a crypto cracking, say through quantum computing, and now everybody's vote gets disclosed. And we can say this is FUD or fear, uncertainty, and doubt, but it's the reality is we're seeing the threats of quantum now, and we're also seeing the problems that have happened with other blockchain related technologies like Bitcoin that have enabled theft of data and theft of Bitcoin currency. So we can't take those risks with voting. And how scalable are the failures? We know how to quantify the theft of an individual or ballot box stuffing with individual ballots. That's a retail level threat. But blockchain attacks are wholesale. If somebody can infiltrate the devices, infiltrate the software, say with a supply chain attack like we saw in the case of, what was it called, just the other week, where the software is modified before it's installed or as part of an update, then everybody can get wiped out at once. So is it a good idea? There's some strong reasons that we might hope it is. It could increase the turnout, except as Audrey said, it doesn't. The studies have shown that that Estonia is the only place where turnout went up, and it took 15 years before they saw an increase in turnout with online voting. It could enable access by people with disabilities. Unclear how well that'll work, but it's possible. It may make it easier for people who live far from a polling place or during COVID. Those are certainly positives, but the downside is it increases the opportunity for hacking. It's not equally available to everyone. Most or many people will not have access to a device that can participate. And what do you do if there's a controversy about the results? So we can look to the experts, the National Academies of Science, which has the role established in law to advise Congress and the president. They say just don't do it. We're not ready for it. And I tend to believe the scientists. This is one thing we've seen over the past year in particular, is believe the scientists. The scientists are telling us don't use internet voting, don't use blockchain voting. But are there places in elections where blockchain could help? Absolutely. Voter registration systems could be improved. We could do a lot of useful stuff with online absentee ballot requests, perhaps using reporting election results, but digital signatures are probably good enough for that. So before I wrap up, because I still have 2 minutes, I do want to comment about some of the concerns that, well, why can't we just rely on an app sitting in our phone? Well, apps in the phone themselves, they have supply chain problems. We've seen there are frequently bugs in apps. A lot of times it's just an error. It's not intentional, but they might record the wrong thing. You say vote for Smith and they show you Smith on the screen, but they actually record Jones. That sort of thing happens more frequently than we might want. Even if the app is perfect though, there may be other apps in your phone or your other device that are observing what that app is doing and inferring how you're voting and reporting that to someone else. And you can say, well, that's completely abstract or that's completely untenable. In fact, it happens. There are apps that watch what you do and then they report to other places, even if they can't directly observe it using what are called side channels. So if we believe in the secret ballot, we can't go to this technology. We need to recognize that paper isn't perfect, but it's much better and it reduces the threat to elections overall. And finally, I want to wrap this up because I know I have 45 seconds left, is to just reemphasize the threat of retail versus wholesale attacks. Blockchain is an attacker's dream because once, if everyone goes to blockchain voting, then an attack will be much more scalable for the bad guys, for the attackers, than it is for the defenders. Thanks very much.
Thank you so much. And I know people are sort of chomping at the bit, wanting to address each one of those topics, but we're going to have to move on.
Well, that's fair, because I'm going to want to address each of the points that other people will make as well.
Exactly. And listen, we're going to try to make some time for that, but I'll talk later about how maybe we can create a mechanism for that.